Today, we're going to walk through creating a new structured data set from unstructured imagery using a computer vision model and then using the extracted data within Tableau. In this example, specifically, we will be processing aerial imagery with a vehicle detection model hosted on app.modsy.com, and all the code and a step-by-step walkthrough is also available on docs.modsy.com, so feel free to use those resources to follow along. Our dataset basically looks like this. Hundreds or thousands of georeferenced tiles of a geographic area that could be hundreds of square kilometers large. Our task is to count every single vehicle in the imagery set. To complete this, we'll be using Modsy's Vehicle Detection in Aerial Imagery model. This is a computer vision model that uses aerial imagery as an input and simply outputs bounding boxes and confidence scores for each vehicle identified. So first things, we need to load our source data within Tableau's Prep builder. We connect to a file listing every single image that we'll be using in this flow. This is all of our source data and simple addresses, nothing too special. As we add it, Tableau will attempt to parse that data, but we just need to tell Tableau that each line is its own unique location. Next, we're going to add a script. We could add an R script. I'm partial to Python, so we'll be using Tableau's Python server or TabPy. For the content of the script, we can again jump over to Modsy, where we will copy the Python example script that Modsy helpfully provides. We'll be pasting this into a script of our own, and I've only made a few minimal changes. I've added our own URL, and then for this input source data object, I've modified it to use Tableau's data frame representation, and I've expanded it with a for loop to include all the source data files we want to process instead of just one like in the example. This final line here converts the results from the JSON format returned by the model and into the data frame format used internally by Tableau. The last difference here is this output schema, which is simply a helper function to let Tableau know that we will be returning decimal data and string data in that data frame. So jumping back to Tableau Prep, we can now load this script file that we've just created, and we paste in the name of the function that we're calling within that script. Tableau automatically loads these latitudes, longitudes, image name, and score columns that we're expecting. From here, I'm simply going to add an output, although we could create additional steps. We're also going to output that to a static file and keep it within the .hyper format. And with that, I'll run the flow. We see that the flow kicks off and we get a nice countdown. If desired, we can jump back to Modsy and view this job in real time as it completes. It looks like it's already completed, but we can jump into the intermediate steps if we want to look. Jumping back to Tableau, indeed it has finished. It only took about 15 seconds. And the longitude and latitudes look about correct. The final step will be to load this data into Tableau Desktop. We're going to go ahead and connect to that file we just generated. We see the same columns, the latitudes and longitudes. So we'll go ahead and create a worksheet and load those locations. Tableau helpfully generates a map, and we see it centered on LA, which we do expect based on the source data. By changing these to dimensions, we see the discrete locations of every single vehicle appear, and they do look like vehicles parked along roads and within parking lots. As a final check, we can load in a background map, and we see indeed freeways, roads, and parking lots in the imagery. So to recap, we loaded unstructured imagery data. We processed that data through a computer vision model hosted on app.modsy.com, and we saved the extracted structured data into a Tableau data store for further analysis. If you have any questions, please don't hesitate to reach out, and I hope this walkthrough was helpful. Thank you.